Welcome to our exploration of ethics in genomic research. As science advances, the study of genomes opens new doors for medicine, agriculture, and understanding life itself. But with these opportunities come significant ethical questions. How should we balance scientific progress with respect for individuals and communities? In this video, we'll journey through the core ethical principles, real-world dilemmas, and the responsibilities of researchers. Let's begin by understanding what makes genomic research unique and why ethics are at the heart of every discovery. Genomic research involves studying the complete set of DNA in an organism. This field has revolutionized our approach to health, disease, and evolution. Unlike traditional genetics, genomics looks at the big picture, analyzing thousands of genes at once. This scale brings both promise and complexity. The information uncovered can be deeply personal, affecting not just individuals but their families and communities. That's why ethical considerations are more important than ever in this rapidly evolving field. The foundation of ethical genomic research are several key principles: respect for persons, beneficence, and justice. Respect for persons means honoring autonomy and informed consent. Beneficence requires researchers to maximize benefits while minimizing harm. Justice ensures fair access and distribution of research benefits. These principles guide every decision from study design to data sharing. Let's see how they apply in real-world scenarios. Informed consent is a cornerstone of ethical research. Participants must understand what the study involves, what data will be collected, and how it will be used. In genomics, this can be challenging because the implications of genetic data are complex and long-lasting. Researchers must communicate clearly, ensuring participants know their rights and the potential risks. This process builds trust and protects individuals from harm. Genomic data is uniquely identifying and sensitive. Protecting privacy is crucial, as misuse could lead to discrimination or stigma. Researchers must safeguard data using secure storage and strict access controls. Confidentiality agreements and de-identification techniques help protect participants. However, as technology evolves, so do the risks. Ongoing vigilance is necessary to maintain trust and protect individuals' rights. Sharing genomic data accelerates scientific discovery, but it also raises ethical questions. Who owns the data? How can we balance open science with privacy? Researchers must navigate these dilemmas, often guided by policies and participant preferences. Transparent communication about data sharing plans is essential. Ultimately, ethical data sharing respects both the needs of science and the rights of individuals. Should participants receive their genomic results? This is a complex ethical question. Some findings may be medically actionable, while others could cause anxiety or confusion. Researchers must decide what, when, and how to share results. Clear policies and support systems help participants understand their options and the implications of their data. Respecting individual preferences is essential in this process. Genomic information often has implications beyond the individual. Family members may be affected by findings, raising questions about disclosure and consent. Researchers must consider the rights and wishes of both participants and their relatives. Balancing privacy with potential health benefits for family members is a delicate ethical challenge that requires sensitivity and clear communication. Genomic research can impact entire communities, especially when studying specific populations. Engaging communities in the research process builds trust and ensures that studies are respectful and relevant. Researchers should seek input, share findings, and address concerns. This collaborative approach helps avoid exploitation and promotes ethical, inclusive science. Justice in genomic research means ensuring fair access to participation and benefits. Historically marginalized groups may be underrepresented or exploited. Researchers must strive for inclusivity and equity, avoiding bias in study design and interpretation. Fairness also means sharing the benefits of research, such as new treatments, with all communities, not just a privileged few. Research involving children presents special ethical challenges. Children cannot provide informed consent, so parents or guardians must decide. Researchers must consider the child's best interests and future autonomy. Some findings may affect a child's life for years to come. Ethical research with children requires extra care, clear communication, and respect for families' wishes. Some groups, such as those with limited resources or education, may be especially vulnerable in genomic research. Ethical guidelines require researchers to protect these participants from exploitation and harm. This means providing extra support, ensuring understanding, and respecting cultural values. Fair recruitment and benefit sharing are essential to uphold justice. Genomic information could be misused, leading to discrimination in employment, insurance, or social settings. Laws and policies exist to prevent this, but risks remain. Researchers must be aware of these dangers and work to minimize them, both through technical safeguards and advocacy for strong legal protections. Genomic research often crosses borders, involving international teams and participants. Ethical standards may vary between countries, creating challenges for collaboration. Researchers must navigate different laws, cultural norms, and expectations. Open dialogue and shared ethical frameworks help ensure that international projects respect all participants and uphold high standards. Benefits from genomic research. Ethical practice requires that the advantages of new knowledge, treatments, or technologies are shared fairly. This includes returning results to participants, supporting local healthcare, and ensuring that profits do not only go to corporations. Benefit sharing builds trust and supports long-term partnerships. Genomic research often involves diverse populations with unique cultural beliefs about genetics and health. Researchers must approach these differences with respect and sensitivity. This means learning about local customs, seeking guidance from community leaders, and adapting research methods when necessary. Cultural sensitivity prevents misunderstandings and promotes ethical, inclusive science. Technologies like CRISPR have made it possible to edit genes with unprecedented precision. This raises profound ethical questions. Should we edit human embryos? What are the long-term consequences? Researchers must weigh the potential benefits against the risks and unknowns. Public dialogue and careful regulation are essential as we navigate this new frontier. Who owns genetic discoveries? Patents and intellectual property rights can drive innovation but may also restrict access to important technologies. Ethical research balances the need for incentives with the public good. Open science initiatives and fair licensing agreements help ensure that discoveries benefit everyone, not just a select few. Sometimes, genomic research uncovers unexpected information unrelated to the original study. These incidental findings can have significant health implications. Researchers must decide whether and how to share this information with participants. Clear policies, ethical review, and support systems are essential to handle these situations responsibly. Ethics committees, also known as institutional review boards (IRBs), play a vital role in genomic research. They review study protocols, assess risks and benefits, and ensure that research meets ethical standards. These committees provide oversight and accountability, helping to protect participants and maintain public trust. Transparency is essential for ethical genomic research. Researchers should clearly communicate study goals, methods, and potential conflicts of interest. Open sharing of results and data within privacy limits builds trust with participants and the public. Transparency also helps prevent misconduct and supports scientific progress. Genomic data can be misused for purposes like surveillance, eugenics, or unauthorized research. Ethical guidelines and strong oversight are needed to prevent such abuses. Researchers must be vigilant, report concerns, and advocate for responsible use of data. Protecting participants from harm is always the top priority. Engaging the public in discussions about genomic research helps build understanding and trust. Researchers should share information, listen to concerns, and involve communities in decision-making. Public engagement ensures that research reflects societal values and addresses real-world needs. Biobanks store genetic samples for future research. Managing these resources raises ethical questions about consent, privacy, and long-term use. Participants must understand how their samples will be used and have the right to withdraw. Biobanks must operate transparently and respect participants' wishes at all times. Research involving indigenous peoples requires special ethical considerations. Past abuses have led to mistrust, so researchers must approach these communities with respect and humility. This means seeking permission, involving community leaders, and ensuring that research benefits the community. Ethical engagement helps repair trust and supports meaningful collaboration. Direct-to-consumer genomic tests are now widely available. These tests raise ethical questions about accuracy, privacy, and the potential for misunderstanding results. Companies must provide clear information and protect customer data. Consumers should be aware of the risks and limitations before making decisions based on test results. Artificial intelligence is increasingly used to analyze genomic data. While AI can reveal new insights, it also raises ethical concerns about bias, transparency, and accountability. Researchers must ensure that AI tools are fair, explainable, and used responsibly. Ongoing evaluation and oversight are essential to maintain ethical standards. Conducting genomic research in low-resource settings presents unique ethical challenges. Researchers must ensure that studies are relevant and beneficial to local communities. This includes building local capacity, respecting local priorities, and avoiding exploitation. Ethical research supports sustainable development and health equity. Genomic data may be stored for decades, raising questions about future use and consent. Participants should be informed about how long their data will be kept and for what purposes. Researchers must review storage policies regularly and allow participants to withdraw consent if they choose. Genomic research is not limited to humans. Studies involving animals raise their own ethical questions about welfare, consent, and the impact on ecosystems. Researchers must follow strict guidelines to ensure humane treatment and consider the broader consequences of their work. Some genomic research has dual-use potential, meaning it could be used for both beneficial and harmful purposes. For example, knowledge about pathogens could improve public health or be misused for bioterrorism. Researchers must assess risks and benefits and follow regulations to prevent misuse. Publishing genomic research requires transparency and honesty. Researchers must avoid plagiarism, falsification, and selective reporting. Ethical publishing ensures that findings are reliable and that credit is given where due. Journals and institutions play a key role in upholding these standards. Conflicts of interest can arise when researchers have financial or personal stakes in the outcome of their studies. Full disclosure and management of conflicts are essential to maintain trust and integrity. Institutions should have clear policies to identify and address potential conflicts. Ethical conduct doesn't happen by accident. Researchers need ongoing training in ethical principles, regulations, and best practices. Institutions should provide resources and support to help researchers navigate complex situations. Continuous education helps maintain high ethical standards across the field. When ethical breaches occur, swift and transparent action is necessary. Institutions should have clear procedures for investigating and addressing misconduct. Protecting whistleblowers and learning from mistakes are essential for maintaining public trust and improving future research. Commercial companies play a growing role in genomic research. Ethical challenges include balancing profit motives with participant welfare, ensuring transparency, and protecting consumer rights. Companies must adhere to the same high ethical standards as academic researchers, with oversight from regulators and the public. Genomic research generates massive amounts of data. Managing, analyzing, and sharing this data ethically is a major challenge. Researchers must ensure data quality, protect privacy, and avoid misuse. Big data offers great promise, but only if handled responsibly. Predictive genomics can forecast disease risk, but also raises ethical questions about anxiety, discrimination, and informed decision-making. Researchers must communicate risks clearly and support participants in understanding their options. Ethical predictive genomics empowers individuals without causing harm. Genomic research offers hope for rare disease patients but also presents unique ethical challenges. Small sample sizes can threaten privacy, and findings may have profound implications for families. Researchers must handle data sensitively and provide support for participants facing difficult choices. Genome-wide association studies (GWAS) search for links between genes and traits. These studies require large, diverse datasets and raise questions about consent, privacy, and data sharing. Researchers must ensure that participants understand the scope of the study and that data is used ethically. Pharmacogenomics studies how genes affect drug response. This research can improve treatment but also raises concerns about privacy, discrimination, and access to new therapies. Researchers must ensure that findings are used to benefit all patients, not just a select few. Genetic counselors help people understand and make decisions about genomic information. Ethical counseling requires empathy, clear communication, and respect for individual choices. Counselors must avoid coercion and support clients in making informed, autonomous decisions. Prenatal genomic testing can provide valuable information for expecting parents, but also raises ethical questions about choice, privacy, and potential discrimination. Researchers and clinicians must provide balanced information and support families in making decisions that align with their values. As genomic research continues to evolve, new ethical challenges will emerge. Ongoing dialogue, education, and policy development are essential to keep pace with scientific advances. By staying vigilant and committed to ethical principles, researchers can ensure that genomics benefits society as a whole. Ethics are the foundation of responsible genomic research. By respecting participants, protecting privacy, and sharing benefits fairly, researchers can build trust and advance science for the good of all. As we look to the future, a strong ethical framework will guide us through new discoveries and challenges. Thank you for joining us on this journey through the ethics of genomic research.